In this video, we will move ahead uh, after discussing average rate and instantaneous rate of reaction. Then we came to term rate law. There we saw rate expression or rate equation. Now, one thing which we have to see is how to write rate of reaction in form of stoichiometry of a chemical reaction. So let's start. Rate of reaction in form of stoichiometry of reaction. And this is the first topic from which I'm going to start today's explanation. So let's take a hypothetical example, a hypothetical equation. M1A reacting with M2B, giving in product N1P plus N2Q. Here the reactant is A and B and the product is P and Q. M1, M2, N1, N2 is the stoichiometry of the respective reactants and the product. So for finding rate of reaction, we all know that rate of reaction is change in concentration of reactant or product with respect to time. So firstly, we will calculate that what is the rate of disappearance of A in this given chemical equation. We will find rate of disappearance of A. Rate of disappearance. Here disappearance means consumption, at which rate this A is being consumed in the reaction. So rate of disappearance of A equals to del concentration of A by niche dt, and here minus sign would be present. Minus, once again I am telling, it is representing decrease in the concentration of A as the reaction proceeds. In the same manner, we will find out rate of disappearance of B. It would be equal to d concentration of B by dt, and minus sign would be present over here again, as B is the reactant and its concentration is continuously decreasing as the reaction proceeds. Now rate of appearance of P. Here appearance means formation, because A and B are reactant, it is being consumed and is being converted into product P and Q. So rate of appearance of P means rate of formation of P. It will be equal to d concentration of P by dt. Plus sign would be present because it is being formed in the reaction. And finally, rate of appearance of it would be equal to d concentration of Q by dt. So these are some of the rate. First one is rate of appearance of reactant A, rate of disappearance, of reactant A, rate of then disappearance of reactant B, rate of appearance of product P, and finally the rate of appearance of product Q. These all are the rate of respective reactant or product. These all are the rate of appearance or disappearance of respective reactant or product. These two are reactant and these two are product over here. But for finding rate of reaction, here stoichiometry will be used. So rate of reaction will be calculated on the basis of concentration of the reactant or the product. We can take any one of them from here. Any one of them can be used to calculate the rate of the reaction. So the rate of reaction will be equal to 1 by m1 into dA by dt with negative sign, or will be equal to 1 by this one, 1 by m2 into minus dB by dt, or 1 by n1 into dP by dt, or 1 by n2 into dq by dt. So for calculating the rate of the reaction, we have to take any one from the above, either from the reactant or from the product, and stoichiometry will be used in this form. So rate of the reaction, rate of this hypothetical reaction which is given over here, the rate of this hypothetical reaction will be equal to any one among them, will be equal to any one among them. It may be equal to 1 by m1. Here m1 is the stoichiometry which is being present over here. This m1 is being placed over here, and into this is minus dA by dt, means rate of disappearance of A. In the same way, 1 by m2, this m2 is again, this is stoichiometry of B, and it will be equal to rate of reaction will be equal to 1 by m2 into minus dB by dt. In the same manner, we can take the concentration of product also, and along with their stoichiometry. So for any hypothetical reaction or any given reaction, we can use the stoichiometry for calculating the rate of reaction in this manner. And one thing which we have to keep in mind over here is that stoichiometry is placed in reciprocal form over here. Let's take one example for this, a chemical reaction 2Hi, hydrogen iodide, giving on splitting H2 plus I2. We have to write the rate of the reaction. So the rate of the reaction for this given equation is rate of reaction is equal to, taking the stoichiometry, 1 by 2 into minus d of Hi by dt. We can also take from product side also, or we can say it will be equal to 1 by, stoichiometry is 1 over here, so 1 by 1 we will not show, we will directly write dH2 by dt, or we can also take this one for calculating and the rate of the reaction, concentration of I2 by dt. So for this chemical equation, this is the rate of the reaction. So in the same manner, we can calculate the rate of reaction using the stoichiometry of the chemical equation in any manner, in any of the chemical reaction. In the same way, we can give the expression for the rate of reaction. Now moving towards the next topic, that is called as order of reaction. Order of reaction. Once again, I am going to take a hypothetical reaction, A reacting with B giving some product. If we will write the rate equation or the rate expression for this given hypothetical chemical reaction, then it would be equal to rate equal to K concentration of A into concentration of B raised to some power x and y. This is the rate equation which is being written for this above hypothetical chemical equation. Now in this expression, this rate expression, this x is called as the order of reaction. This x is called as the order of this reaction with respect to A. Here, what is this x? X is order of reaction with respect to A. Also, what is this y? This y is also the order of the reaction but with respect to B. Y is equal to order of reaction with respect to B. And x plus y, the sum of this two power, this would be called as overall order of reaction. This is overall order of reaction. Yani for if we will take x only, it would be the order of this reaction but with respect to A, means this first reactant only. If we will take y only, then it would be also the order of the reaction but with respect to B. But if we will take the sum of x and y, if we will take the sum of this power, then it will give the overall order of reaction. So the topic which we are studying over here is the order of reaction. And what is this order of reaction? This order of reaction is sum of the power of concentration of reactant in rate law. Now I'm going to define order of reaction. What is this? It is sum of power of what? Power of concentration of reactants. Power of concentration of reactant in rate law expression. In this rate law expression, this is the rate law expression. In this rate law expression, the sum of power of this concentration is called as the order of reaction. And some important point to note down over here is order of any reaction. If we will calculate order of reaction, it can be positive, it can be negative, it can be zero, it can also have fractional value. Order can have positive, negative, zero as well as fractional value. And for any reaction, order is determined experimentally. It is not a theoretical value. If we have to find order of any reaction, it can be determined experimentally only. It is not theoretical one. Now on the basis of order of reaction, we can classify reaction on various type. On the basis of order of reaction, a reaction could be called as zero order reaction. It could be called as first order reaction. It can be called as second order reaction and so on. So this is the classification of reaction on the basis of order. If the reaction is called as zero order reaction, then its order will be 0. First order reaction, its order will be equal to 1, and for the second order reaction, its order would be equal to 2. And we all know that what is order? Order is nothing, it is simply the sum of this power. So if the sum of this power which is being written in the rate law expression, if the sum of this power is equal to 0, then we will call it as the zero order reaction. If the sum of the power become 1, then we will call it as first order reaction. And if it will be becoming 2, then we will call it as a second order reaction, and so on. Once again, I am going back to the rate expression. The rate expression or rate equation which we have seen in the earlier video. It was something like this. R is equal to K into concentration of reactant raised to some power. So in this expression of rate law, uh, if we have to find the value of K, we will send these two terms on the other side. So it will become like this. K is equal to R by product of concentration of A and B raised to power X and Y. In this expression, the value of K is to be obtained by dividing rate of the reaction with the concentration of the reactant. This is the expression to calculate rate constant. Now coming to unit of rate constant, it would be found with the help of the unit of rate of the reaction and the unit of concentration. The unit of rate of reaction is mole per liter per time. It may be in second, minute, anything else. And here A and B यानी कि concentration. So by concentration raised to some power. So let X and Y be replaced and a power N is put over here. So mole per liter per time and concentration, it will be written as mole per liter raised to the power N. On solving this, so on solving, we will get the unit of K. This unit of K, it will be equal to mole per liter raised to the power 1 by N into time to the power minus 1. This will be the unit for K, meaning rate constant. And if the reactant is gaseous, for gaseous reactant, then the unit of K will become ATM raised to the power 1 minus N into time to the power minus 1. ATM will be used because for a gaseous reactant, its concentration is measured in the term of partial pressure. So this is a small video for the explanation of two things. One, I told you about the rate of the reaction in the form of stoichiometry, and another one is about the unit of rate constant K. And next and the last thing which we studied is the order of the reaction.